Cool. So you use this term asynchronous and multi-rate a lot. Can you tell us why is that significant with the system designer?
Right. So asynchronous is a term that we apply towards the way that the diagram on the LabVIEW System Designer executes, which is a multi-rate model behavior. And this is different from the data flow execution behavior that you see in LabVIEW today. In data flow execution, each node must have data on all its inputs before it can execute, and must provide data on all its outputs before the next node can execute in the diagram. Also in LabVIEW, as we all learned in our LabVIEW Basics 1 and 2 course, the wires dictate the order of execution in a LabVIEW diagram. Now in a multi-rate diagram in LabVIEW System Designer, each node runs asynchronously or at its own rate, and it can produce and consume data at different rates as well. Now, and then the wires on the multi-rate diagram specify the communication between each asynchronous VI. Now, you can program this way in LabVIEW today using a series of loops and queues. It's just that the multi-rate diagram provides you a native representation that better resembles how these applications execute.
Cool. So how does this apply to the application that we just built? What are the different rates that you have to deal with in this application?
So yeah, we can acquire data from our I/O adapter module, again, at 100 megasamples per second, the down converter at 25, and the demodulator at 5 megabytes per second.
That's cool. Okay, so we can see now you have asynchronous VIs, you have IP that you brought in, everything's connected by wires, so it's just like LabVIEW. Yep. But how do I actually get data between the different pieces of hardware on the system designer?
Right, so as you would expect, as we can use the asynchronous wire to pass data from one asynchronous VI to the next on the same target, we can actually wire data from one asynchronous VI to another on 2 different targets. And here in our application, what we're going to do is wire a start signal from our host application, from our host target, down onto our FlexRio device. And then the system designer actually scripts the code that's necessary to implement that communications interface in the background.
Cool, so now if I want to just get data from one FlexRio to the other, then I can wire from FlexRio to the host, and then from the host to the other FlexRio to transfer the data, right?
Oh, Mike.
You think that's funny? Is that a bad way to do it?
We could do that, but actually we want to show you some new technology that we're working on that actually allows you to stream data between multiple devices over the PXI Express backplane without sending any data back to our host controller. Now, in order to do this, we're using 2 prototype PXI Express FlexRio FPGA modules. And they are capable of transferring data with extremely high bandwidth and very minimal latency. And this is exactly what we need to get data from our first FPGA to our second FPGA. Now, this is a very challenging task, spanning physical hardware, device firmware, and driver and application level software. And if we were doing this from scratch, it would take a ton of engineering time. But with the LabVIEW System Designer and NI hardware, we can do it in a matter of seconds.
So obviously it sounds like streaming data from one device for this application would be really useful. How do you do it with the LabVIEW System Designer?
Well, it's as simple as wiring from one asynchronous VI on the first FlexRio to the asynchronous VI on the second FlexRio.
That's it?
That's it.
So with that wire, you're now going to stream high-speed data between 2 pieces of hardware over the PXI Express bus and not go through the host.
That's right.
Okay, so you told us you were going to show us how to build this. Can you actually run this application now?
We sure can, Mike. Let me turn on the monitor here so we can actually view the output. But of course, as you can see from our system diagram, most of our code is actually running on the FPGA. And as anybody who's programmed LabVIEW FPGA before, or any FPGAs, you have to go through a long compile process. So instead of doing that, we're actually going to switch to another pre-compiled system diagram that will actually run this application. So when Ryan presses the system run button, we'll actually see the HD TV video come out here on the device.
Okay, so we have liftoff of a LabVIEW System Designer built application. Very nice. Now, you guys really weren't kidding. You actually showed us a lot. You showed us that you can integrate IP easily from different sources. You can create high-speed, multi-rate, asynchronous diagrams. And you can do high-speed streaming of data across PXI Express, all by connecting wires and connecting blocks on a diagram. That's a really impressive demo. Thanks a lot, guys.
Thank you.